many years I was running the JBoss Application Server team. Do you know JBoss? Yeah. And the last 5 years I'm mostly involved with Quarkus. So who has heard about Quarkus before? Alright, it's a good opportunity now to see Quarkus in action with a bit of, AI magic. So, do you know this movie? Yes, maybe? Yeah, anyway. I saw this movie when I was small, and it was very interesting because this boy hacks into the computer of the Pentagon, and he's about to start a nuclear war thinking they're playing a game. And the computer is intelligent and smart. So as a kid, that was very, inspiring to me. So I started, doing hot computers, playing, studying, working on it, only to find out the next 30 years that, this AI thing is just boring. Nothing worked. AI never really delivered on the promise. And for the most part, when we were talking about AI in those past years, we were thinking about systems programmed in Lisp or in Prolog. We had things like the chatbot, Elisa, pretending to be smart, but it wasn't that smart. But there were a few breakthroughs like Deep Blue, like this very strong computer and an army of engineers behind it. They managed to beat Kasparov in a game of chess, so that was like a big thing back then. But for the most part, like those past years, when you thought about AI, it was like science fiction. Terminator, Odyssey 2000. So. But things actually evolved slowly without really much noticing. So there was this game, Jeopardy, where this AI won. Back in 2011, Jeopardy was the game. Today we have self-driving taxis in US. There are a couple of states where they're actually driving on their own. They can pick up customers. I'm sure you've seen Boston Dynamics robot jumping and doing things. But I think one key development was the work that happened in Google back in 2016. There was a couple of papers coming out, the famous Transformer paper. And this manifested in a few key events, there's this game called Go. It's a very complex game, and they wrote a program that could beat the best player in the world. So that was like a big thing. But a bit after, they wrote this version called AlphaZero Go, in which the algorithm with zero knowledge, the program just was taught the rules of the game. That's it. So it trained on itself, and within 3 days, it beat AlphaZero that beat the best player in the world. And they repeated the experiment with chess, another very nice game. And AlphaZero chess in 4 hours managed to teach itself better chess than any other software written ever. So that showed that something really changed. And then things got crazy. This is like 2 years ago. People start generating pictures with prompts. So this picture won an art competition, which is very nice. So it's the picture plus a bit of photoshopping. And now we're asking questions, okay, like who drew the picture now? Is it like the prompter? Is it the algorithm that was trained with millions of pictures? Can it be copyrighted? So we have now other questions to answer. So generative AI changed the rules of the game because it started doing things that were creative, that we thought, those are for people. Machines will never do that. So this happened. And then right after that, of course, ChatGPT was released. Have you used ChatGPT? Yeah, okay. So what ChatGPT did was it brought this generative AI technology to everyone. So all of you, your children now, they're typing when they want to do an exercise at school or something. And ChatGPT reached 1 million users in 5 days, which was like a record at the time. So generative AI is now here. It's accessible to everyone, so it's really a revolution. Just very few things. If you have you played yourself with LLMs, like writing code for LLMs? Just no. All right, you're at the right place now today. So I'll give you like a very quick introduction how those things work. So we have what we call the foundation models, which are made by those people that have tons of hardware. So they have tons of hardware, clusters, GPUs, and what they do is they essentially read all the internet, they feed it into this model that trains on its own, and takes millions of dollars to do this thing. It might take like a month, whatever. And then these things, all it does is, if you give it a string, it can generate the next word. So if you say, once upon a, this thing will say, oh, time, once upon a time. That's that's the usual way to continue the sentence. But the magic here is that you can give it like a paragraph, and it can generate a whole book. It can, it will keep going and keep going. So that's the base of the, technology. That's the foundation model. What we do next is we do what we'll call the fine-tuning, which is we teach this foundational model to do something more useful. So in order for this to have this behavior where, you have a chat assistant, you ask a question, you get a reply, you ask a question, you get a reply. What they do with this fine-tuning phase is they take a lot of curated documents. So the first phase was automatic. We just gave it the internet. In the second phase, we took questions and answers that we know they're correct, and we give it to the model, and we train it again. Question and answer. We train it with, less documents this time, not the internet. Let's say we have, some thousands question and answers. So the model now learns to become an assistant. You ask a question, you get an answer, using all the knowledge it got in the previous phase. And there are some extra steps in this process where you try to make the model more behaving, helpful, honest, harmless. So if you ask it, can you teach me how I can make a bomb? It will say, oh, sorry, I know, but I will not tell you. Or if you wanted to avoid, biases, gender or sexual stuff, you can teach it to behave. So this is roughly how it works. But why you tell me all this stuff? I'm not a data scientist. Do we have any data scientists in the room? I thought so. Oh, we had one. Yes? No? Yes. So we are developers, so we don't care about this stuff. So for the developers, you hear a lot about AI, but at the end of the day, AI is an API that you call in your code. You call, you get back a reply, something like this. But there are two key qualities. One is the response that we'll get is not deterministic. I ask something, I get a reply. If I ask the same thing, I might get a different reply. Okay? And there is like a control that controls like how creative the answer is. This is called the temperature. If I say temperature is 0, I get a more boring deterministic answer. If I say temperature goes to 1, I get a very creative answer. So that's one thing. The other thing is, every time I talk to this, it forgets everything. So it's stateless. When I go to ChatGPT and ask a question and I get a reply, and then ask another question and I make a discussion, there's something in between that manages the state. So every time you ask a question, it sends back everything else that went before. So like the discussion keeps build up. So you have to send everything again. This is the context. And every model has a different size of context it can understand, which is a constraint of those models. Okay, so it's an API, it's a bit peculiar, but the thing is you can do a lot with this API. Initially, when LLMs, large language models, came out, we said, oh, we will do a lot of fine-tuning, blah, 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 but we don't have to in many cases. You can do a lot with just using one of the popular models out there. And in our team, in the Quarkus team, we have another member here sitting in front. He has another talk later that I suggest that you go, Stefan. We were looking into, ChatGPT, these technologies, how do we integrate, and it was really tough until this project came out, LangChain for Java. So there's a popular library in the Python space called LangChain, and LangChain for J implements those ideas in Java. So just to make it simple for you, do you know Hibernate? You know what's Hibernate? Great. So LangChain for J is the Hibernate for LLMs. It gives you the same API to talk to different LLMs, and it can handle a lot of the complexity, like managing state, memory, parsing stuff. There's this thing called, if you were in the presentation before, called RAG, Retrieval Augmented Generation, which is a fancy way to say, when I make a discussion, I want to stuff extra data to help the model answer. That's it. You can hear about vector databases, but you can do that. You might not have to do that, and I'll show you some ways to, go about it. But anyway, this is the Hibernate of LLMs. And in Quarkus, we integrated with the library, with Quarkus. We work very closely with LangChain team. And in Quarkus, we make LangChain for J even more interesting because it integrates nicely with everything else we have in Quarkus. We have also something called the dev mode, the developer mode. This is very special with Quarkus, and I'll show you an example of that. It helps when you write this type of applications, you have to test things quickly. I want to test the prompt, look, check the reply, try something else. It really helps. In Quarkus, everything we integrate, it's super performant. It lets you compile to native with just an extra flag. I want this in native. For Quarkus, it's super simple. And you get some extra features for free. Metrics, tracing, auditing, this all works out of the box. So, okay, show me some codes. I hope it works, and the internet is fine and everything. So, no, I don't have to stop this, sorry. Yeah. So the way you start with Quarkus is you go to the website. This is quarkus.io, okay? And I'll make an application from zero, so there will be no cheating. I do everything in front of you. I hope it works. So one way to start with Quarkus is you say, oh, I want to create an application. So you say, yeah, I want to start coding. So we have this like initializer thing where in Quarkus we have extensions for different things. We have more than 600 extensions, so we have everything. For this example, I'll do like a web application, so we have something to call. So I say, yeah, I want REST. And then you can filter here, and you can say LangChain. So I have 12 extensions that are specific for AI. So this is the list here. And normally the extensions is either like some vector database, so I can do proximity search, or some specific integration with a model. So I want to talk to ChatGPT. I want to talk to Vert.x IO. I want to talk to Gemini or Watson or Azure OpenAI. So the integrations are here. So here I have LangChain OpenAI. So that's ChatGPT basically, all right? So I have two extensions, generate my application, download it. So it's here. Yep. So if I go here to my command line, just unzip it. Zip. So I'll just unzip it in a directory. I'll go there, cd, and start the ID. All right. So the way you code with Quarkus, normally you go into the IDE. You can use Maven completely. I have also installed the Quarkus CLI. So this one, Quarkus, okay? It's easier, so I can say Quarkus dev. And this will compile the code and start Quarkus in this special developer mode where I have extra conveniences. So this will start, Quarkus is here. All right, it's running, and you can say, W. So now I'm connected to my app that I just created. It's like it includes a bit of skeleton code to create, return like a hello world. The cool thing when I have dev mode, if I have this dev UI, I can click here, and those are the extensions that are running in my application. If I go back and look at the POM, you'll see basically, I chose those two. I wanted to make a REST application with OpenAI, so that's it. So the other things here were dependencies that were brought in to create my application. Now the cool thing is, I've started, I haven't done anything, but because I said, okay, I'm going to use OpenAI, and the one thing I didn't show you in my environment, I have an OpenAI key, because to talk to OpenAI, you need a key. So I have it already in my environment, so it can pick it up. So with Quarkus, you can do fancy things in the dev UI. So I can go to this extension and say, I want a picture of a Java developer under Hagia Sophia. Oh, and I'll add the cat because Istanbul is full of cats. So if this works, this will ask ChatGPT, can you make a picture for me? And I should be able to see it right here in the dev UI. So here's a developer with a cat writing code in Istanbul. And I didn't have to do anything, right? So let's go back to the code. So this generated app comes with a class that is a hello world. That's just the REST API. So this actually runs. Where is my resource? Yeah. So this runs. So if I go here and say hello, I get back, it's running. Hello from Quarkus AS. Now, every Quarkus presentation will not be complete if I don't do this for you. Just to show you how, great Quarkus is at Istanbul. Bull, yes. You save and then you refresh. And your code is running. Now this is compiled Java, right? It's not interpreted. You can make changes and immediately you see them running, without doing anything. Just Quarkus restarts very quickly without you noticing. So that's okay, we have an application. Let's make it a bit smart. So the way to do it, the way we have chosen to do it in Quarkus is by applying a pattern that looks like a REST client, if you know. Glitter AI service. So I will add an interface here, and I use this annotation. So this is a Quarkus annotation. So what I'm saying here is, whatever I put in this interface, Quarkus use LangChain and whatever extension you have put in the POM to implement it by talking to the LLM. Okay? So if I put here a method like create, I need a way to say to the LLM, okay, what's the prompt? We do it with annotation, so that will be my user message. So this is all you need, basically. Now I have a service that can talk to ChatGPT and get back a reply. And to use it, I can go back to my resource. This is standard Java here. There's nothing Quarkus specific. So you can say, all right, inject, oops, sorry. Oh. Inject an implementation of this interface I just created, and I can, use it like this. All right, simple. So if I go back here and say, refresh. Hello, it's great to hear from you. How can I assist you today? This is ChatGPT answering, okay? In a few lines of code, I'm talking to ChatGPT. Let's make it more interesting. So let's say this Quarkus thing, we want it to be dynamic. So let's do this. So you see that essentially the prompt is a template, and I can replace stuff in the template. So whatever goes here, it will go into the prompt. So if I go here and say, Dimitris, it's my name, save, refresh. Yep, I didn't save. No, I saved. You get nice errors with Quarkus, by the way. So, hello, Dimitris, how can I assist you today? Again, ChatGPT talking. Let's continue. Whenever you talk to these prompts, there is a thing called the system prompt. The system prompt is what tells the model how it's supposed to behave. So let's do this. System message, again, an annotation. And this can be like as big as you want, right? So I'll do a multi-line thing here. So I do this. Professional. So Troy Hawk, if I write it correctly. It's a real person that runs a show by greeting people in fancy ways. So with this prompt here, I saved, if I repeat, the call. Now I'm getting something fancy. Hi, Dimitris. Welcome to the virtual realm of greeting salutations. I'm Troy Hawk of the Greeters Guilds at your service. How delightful to make your acquaintance here today. How can I assist you? So it gets funny now and, creative. And if I call it again, you'll see I'll get a new text completely. GPT, it gets creative. Now, whenever you do things with a LLM, sometimes you want to see what goes on the wire. And in Quarkus, we have this very nice thing here. All the system, all the configuration properties are available. You can filter. There's a thing, I want to log requests to see what goes on the wire. So if I want to log requests and responses. True. The change I'm doing here is reflected back into the code. So if I go back to the code, there's a configuration file. So it's saved here. Quarkus knows about it. So if I just do a refresh, then on the log, I see what's happening. So look what happens. I'm setting request. I'm using GPT 3.5 Turbo, which is the default, GPT model. This is my system prompt. This is my prompt. This is the temperature. And this is the reply. So the system replied with this. Okay. Now you have to realize, again, LLMs are stateless. And one nice way to show this would be here again, in my dev UI, I can actually prompt the model directly. I have this screen can write prompts here and get replies in the dev UI. I can try things. And that should be here in the log. See, my request. Hello, I'm Dimitris, the response. And if I continue the discussion and say, what is my name? It knows I'm Dimitris, but how does it know? If we go back at the log, look here. The second time I've asked it, look what happened. It sent back the previous discussion. Hello, I'm Dimitris. Hi, Dimitris. What is my name? It's Dimitris. So every time you talk to it, Quarkus builds a memory, and it gets increasing and increasing. There are ways to control it. It's a cyclical memory. By default, it's assigned to the web request. So within the same request, if you make multiple calls, they will be chained together. And there are ways to control it, more advanced. So let's continue again with our example. If I want to add more prompts, no problem, you go here in the interface. So let's say we want to ask, what time is it? So that will be time. So I want to tip it, Quarkus to implement this for me using LangChain, and to call it, I'll do like a very quick and dirty thing here. So let's say path. Who am I? How did I call this? Oh, sorry, time. Yeah, sorry, time. Time. All right. Let's find out the time. What do you think is going to happen? I'm sorry, I'm not programmed to tell time. So that's another characteristic of LLMs. They have no concept of time or space. So how we can help it? There's a thing in Quarkus LangChain, OpenAI, which is called like a function or a tool. There are different names to describe this. So let me just stop here so I lose memory, and then I'll do a new file. Class. I'm coding like I would go to any application, so I want a class that will return the time. Time, get current time. And I'll even do that format. Let's say somehow I could specify the format. Turn. So I did a mistake on purpose, like I'm not using the format, just returning the local time. So far, this is nothing special, standard Java, right? What makes it special, if I say here, if I add this annotation, tool. This is a LangChain annotation, all right? Tool. And to connect my tool to my service, I have to go back here, my service, and say, for this service, you can also use tools from this class. Creator tools class. So now this is connected. Oh, yeah, I'll start it. This is a very powerful concept which blows your mind once I show you what it does. Is it started? Yep. So if I ask the time now, it knows the time, 15:11. So it's correct. So what happened here? Let's look at the log. So I'm sending this prompt. What time is it? But in the prompt, because I use this tools annotation, I include this metadata. So I'm saying, look, I also have this function called getCurrentTime that takes a string argument, and you just know that I have this function. And then ChatGPT says, I don't know the time, but this function that you gave me looks interesting. It's called getCurrentTime. So probably it returns the current time. So it replies to me and says, oh, could you call this function for me? And can you pass also this argument? You see, it uses the correct format without, I didn't provide any other information, nothing. I could add extra metadata, extra annotation, but I did it on purpose. I said nothing. So it figured out this function probably does the trick and take this argument and call it for me. So behind the scenes, we call it, your code doesn't have to do anything about this. We call it, we reply back again, the whole conversation. What time is it? The reply by and we include the result of calling the method. So we call the method locally. We put the result in here. This is the result. You see, it's like printing the object, the local date time. So it's a complex format. And ChatGPT parses this, finds the time, and then it replies with, this is the current time. So you can imagine your code, you could have any piece of code that you want to make available to the LLM and just tag it, this method, you can have a complex prompt and it can figure it out. So this is pretty amazing capability. Okay, I'll stop this here. What time is it? Yes. And I'll switch. Now, the same example, now we talk to ChatGPT, but we have the option to talk to a model that's running on this laptop, right? You don't need to talk to Azure or OpenAI. I have this little thing here called Ollama. It's free. You can download it, install it, and in here you can install other open source or free models. So I have installed a couple of models here, and it's really the same application here. So if I show you the code, where is the code? Yeah. Again, it's the same code that we had before, but now I'm using the Ollama extension. Nothing changed. In this code, I've added some extra stuff. I have, this fallback thing. This is a micro-profile standard annotation, which says, if this code fails or timeouts, call this other method. So it will call this one. All right? It's very simple. So let's run it. Quarkus dev. Let's see what happens. So again, it starts, the usual stuff. And if I go here and say hello, now obviously it will take more time because what it does, it calls Ollama. Oops, that was super fast. Ollama loaded Llama 3 and gave me this reply. So you see now it's a different LLM answering. It's a different type of reply. The code is the same, but it's still very creative. If I ask again, no. So this is all running on this laptop. Well, it's a new laptop. It's a fast one, but it gives you an idea what you can do. Now, in this example, to emulate a failure, I have a timeout. So if I set this too low, let's say 2 seconds. If you don't answer in 2 seconds, activate the fallback. And that's the fallback, right? It's very simple to code. And in this example also, I have included an extension for metrics. So if you say metrics, yep. By just including an extension, I can see, how many times this endpoint was called. Yeah, so it's called again, whatever. So if refresh, yeah, Like this was called 2 times. And it took so much seconds for this. You know, you can export this to Prometheus and, you know, do all this stuff. Okay, so you can also use local models by just changing the extension. Let's try another example. This one. Once you understand how easy to, you know, program with Java and LLMs, then, you know, you get ideas for other things. So at some point I thought, oh, what if I write a small translation service? And look how easy to do it. So this is all the AI code you need. Your professional translator translate whatever I give you here in this text. This will be replaced here and translate it into this language. Super simple. So in this example, there's a bit of code to, you know, do like a handle, you know, command line arguments. I wrote this as a command line utility, but the AI part is really just this line here. Okay. So in this directory, I have. Well, let me just execute it for you. Translate. This example, I compile it to native also. What I told you, you know, you can use GraalVM. In Quarkus, you just say Quarkus built native. That's it. So if you execute this one, default is, you know, it will execute like this, and I can start saying, you know, I'm sure this is all Greek to you, and I throw in some French for a good measure. This is an example, my friend. So it translated in the same sentence, Greek and French, without problem. And then if I say, so this is a small English story. Of course, I asked ChatGPT, create a small story for me. And let's translate it using the native. This is native executable. Translate this English story into Turkish. You'll see what comes out of it. Probably you can tell me better if this looks similar. Is it good? I probably is, yes. Yep, okay, good. So, one last example. You get the idea. It's super simple to start writing smart applications or integrate it with your code, because at the end of the day, it's an integration problem. They try to make it's more fancy, but it's just another integration problem. So one last example, the more complicated one that I'll show you today, and then back to slides. This one. All right, again, Quarkus dev. So what's this example? In this example, we have a CSV file with the 100 top movies from IMDb. So those are the 100 movies from IMDb. And what we do in this example is we read the movies and we store them in a SQL database, Postgres. Okay? We just put them into Postgres. And we wrote a small application that lets you, that will create a small chatbot, essentially. And it works like this. Well, you say, this is running. Let's see. I need to say that, Just let me check something here. Yeah. Oop. Yep, okay. So, hello. Can you propose a horror movie for tonight? Yeah, how about watching Aliens for a thrilling horror movie experience tonight? So how did it find Alien? It takes the prompt, we take the prompt, we go to ChatGPT and we say, look, we have this SQL database with this schema, and we have this question. Can you generate a query for me to find the relevant information? And in this example, we get back this query. Look, it's very precise. Select movie name from movie where genre is horror by IMDb rating, give me one result. Okay? And then we send this result again to ChatGPT to make a fancy answer. And we get the answer. So in this example, we essentially implement RAG, retrieval augmented generation, without a vector database, just with a normal SQL database. And you can ask, of course, more complex things. You can say, give me the top 5 action movies of the 90s. Matrix, Terminator, Judgment Day, Leon, and Heat. Cool. And let's see the query that it generated. Select movie name from movie where we look for actions, year of release in the 90s, by rating, give me 5 results. So this was generated by the chatbot. Let's go look a bit of code here. So this is the service that generates the query. So we have a big prompt that explains exactly what we want to do. Okay? And that's the bot. And that's the bot prompt. Okay, so back to my slides. I think I gave you, a good idea how easy to get started, especially with Quarkus and LangChain. It's not science fiction. This works. It can work on your laptop. It really offers like an exciting new world because the things you can do with this stuff is, I don't know, it's up to you now, right? Some ideas. You want to do sentiment analysis, give it a review and it tells you is it positive, negative, the customer is happy or not. You can transform structured data to unstructured. You can summarize, expand, translate, analyze. Sky's the limit. So lots of good stuff. And be careful whatever you do, do it for good. This is a superpower granted to us, to you developers. So let's be, careful with it. And that's it. Thank you very much.